So this is my fully parametric vacuum hose I made for my drill press. Obviously designed to suck out the dirt through the hose so that it doesn't make a complete mess here, especially with things like MDF, which produce a lot of dust and is kind of annoying. So what we have here is the holding clamp on the column here. The hose for the vacuum is just attached by sticking it on. There's a clamp around here, which is part of the deal. And then we have the hose, which can just be adjusted like this, and luckily enough it sticks very well like this. So you can position it however you like, and if you don't need it, you just put it to the side or adjust it so that it fits right under the drill. The only slight disadvantage I've just noticed once I finish it is that this distance steals you some of your travel, because you need to position the drill, you need to be able to slide it under there. But obviously that can be avoided if you mount the drill like this or some way like this. So I shall start the shopvac, and then we will see how it works. So I think we can see that it works really nice. Some dust gets stuck on the sides occasionally because the print is not completely smooth inside, but it does suck away most of it. And now, just for comparison, let's see what kind of mess a similar hole makes without vacuuming it. Well, there you have it. Lots of fine dust. These bits, quite annoying. So I think this is, well, obviously not an invention of mine, but I think this design is quite nice and usable. I haven't tested it on metal yet, but it's probably less of an issue. And it's my shop is quite small, so it's no problem for me to just, when I need it, attach the hose and remove it when I don't. Just put it to the side like this, and it's quite fine, out of the way. Here like this. Yeah, well, there you have it. And since it's quite, I gave it a lot of thought to design it in a parametric way. You can adjust the diameter of this if you have a smaller setup or a bigger setup, just to your needs. And obviously you can also use just the last part of the vacuum hose without this attachment. You can snap it off like this and just use it that way, but it doesn't get all the debris. So this is my design for a segmented vacuum hose. You start with a basic element, which is a link. Vacuum hose is made of several links. They snap into each other. So one of the main parameters is the total length, which goes from center of this sphere to the center of the other sphere. And it defines the total length of your segmented hose. If you want a segmented hose with 54 centimeter long, you make 10 pieces. And once they snap into each other, you will have a 45 centimeter long hose. Another important parameter is this pipe inner diameter, which is the inner diameter of this pipe, which connects the two spheres. The inner diameter here. And what you need to consider that there's always at least a tiny bit of pipe left between these pieces. And by default, the link sphere diameter, which is the diameter of these spheres, is 1.5 times that of the pipe inner diameter. That makes sense to do it to get a reasonable relation between the two. Let me show you what happens if I make this a little bit bigger. Or let's start with making this longer. It's always good to start with this parameter quite long, because these spheres, once they overlap, it may break the design. So make this quite long. And now we fix this by typing in 60 millimeter and make the inner diameter of this connection here smaller. Let's make this 30 millimeter. Now we have this type of connection. Let's go to the other parameters, which is the wall thickness. It should be pretty self-explanatory. The wall thickness of the pipe part here, which is not that important. I would choose a relatively big value to make that stiff. And then we have the link wall thickness, which is the thickness of these spheres. And that needs to be a little bit smaller so that the spheres are still a bit flexible, because this sphere needs to snap inside that one. Let's have a look at the other values, which is the overlay of the spheres. This sphere is, you can imagine it to be 80% of a sphere, because it's 0.8, and this is 60% of a sphere. This outer part of the sphere always needs to be over 50, or the links will simply fall apart. But it cannot be too large, or you will not be able to fit them together. For example, let's make this 80, and you will see it's now quite impossible to fit this side inside that, because you cannot get this diameter through this hole. So let's get back to more reasonable values. The other side is this sphere, which defines how easily the links will disconnect when you bend it. If this is just about half that, you can imagine once it's in there, if you bend it only slightly, it will fall apart. It will open up and then fall apart. You can make this bigger, a bigger value, which will allow for more. Oops. This one bigger, which will allow for even more bending angle before it falls apart, but it will constrain the airflow. So it's always a compromise there. Let's get back to my default values, and when you go back, it's always best to change the length at the end, because you want to avoid these spheres overlapping and destroying the pipe in between at any point. So let me do this. It's 40 millimeter. The other parts are still okay. Oh no, 40 millimeter, and with this was this was 45 millimeter. So that's my default again. You can use this little helper table, which will show you the bending angle if you put two pieces two links together, how much you can bend them before it falls apart. And obviously, if you make this pipe inner diameter smaller, for example, if I make this 30 millimeter, okay, now I broke it, of course. Let's make this a little bit longer again, and then the smaller. Oops. There we go. And now we have more bending angle, 45, because this part is smaller in relation to the size of the spheres. Okay, then we have the gap, which is the gap between this inner sphere and this outer sphere, and that defines how stiff the segmented hose will be, how much this inner surface rubs against this outer surface once the two pieces are stuck together. If you use smaller values, it will get harder to bend the hose, and if you make bigger values, it will get more loose. So, next parts I have are the left and right, which is just the separate parts of one link, which you can use to design your own start and end pieces for the segmented hose. Then we have what I call the inlet and outlet, although also that becomes confusing when dealing with a vacuum hose a little bit. But those are these parts. And you have this, what I call the inlet, which in my my setup connects to the vacuum hose of Makita shopvac. You have wall thickness, it's self-explanatory. You have the transition angle, which is this angle here. This should be about 45 to make it printable. If it's too shallow, it will be difficult to print it without supports. Then we have the inlet diameter, which is the outer diameter here, and it tapers off by 0.5 degree to the outside, so that you can stick the vacuum hose on there. And the outlet is pretty much the opposite part. Again, it has the transition angle here, there, the small part. And then it has the outlet taper, also 0.5 degree, because you stick something like a nozzle from your shopvac, you can stick in here. But these are values you need to experiment with the hardware you have, to adjust for the hardware you have. So then we have a little bit of funny piece, which are these adapter pieces, which let you connect segmented hose with big sphere diameter to one with a smaller sphere diameter. What is it useful for? I'm not 100% sure. Maybe you want to start with a big hose and then end with this very small hose at the area you want to suck debris away or whatever. But this is just a funny part to experiment with. Again, I would choose relatively big total lengths and then adjust the other values accordingly. You can see you only define the smaller spheres here. The bigger ones are given up here with the general sphere and link definition. So let's go back there also. And then we have the final part, which is the shroud. I would always define this at last, because it's a little bit of a finicky part. And this works by starting with your sphere diameter, and then using double that diameter to produce this shroud with a through hole in the middle. The idea is that you can go with your drill through here, and any debris that will be removed from material which you have under here, maybe a sheet of wood, will get sucked away. And the default has a very small hole, because if you change any of the other values too small, this part will get screwed up. So I would pick the through hole, the shroud hole diameter at the very last. For example, I use 55 millimeter to make room for a large Forstner bit to go through there, and to have a little bit of wiggle room. But the tighter you make is obviously the better the suction and dirt removal will be. And if you look at the side profile, this part will pretty much lie directly on your workpiece, and the segmented hose will go away there. So that's a little bit of an overview through my design. Not the cleanest design in FreeCAD. If you open these up and look at it, it's a little bit confusing, but it produces a well-fitting vacuum hose for me. And if you need something to start out, this should be a good option. So now we start with the slicing, exporting and slicing, and you should pretty much have set up your link, which is your main part, and set up your values to your liking. And so let's go through exporting the parts. I start with the link. Then next thing is I take the shroud, which is the end piece of the hose in my setup. And then we need the inlet, where we stick on the vacuum hose. But I need more of this ridge to hold the whole assembly with a clamp to the column of my drill press. So this needs to be longer. Unfortunately, I have no exact value to define this, so I just do a little bit of guesswork here. Total length, I need about 30 millimeter to grab on there, and since it's a total length of 2 pieces, it should work out to about 60 extra, which is 105. Let's check this. Yeah, 30 millimeter, that is pretty much what I need. So I will export this inlet also. Now we have exported the 3 pieces we need: inlet, links, we can double them in Prusa slicer, and our shroud, which is the end piece. So for slicing, I would give you the following advice. Start with just the links, make 2 of them, and then no supports. Just to pieces. With two pieces you can check how well they snap together. That's a good start to work out if this hoses works for you and your printer settings. If it doesn't work out, you need to get back to FreeCAD and adjust the gap, for example, to make them snap together better, or change the ratios between the size of the spheres, the 0.6 and 0.8 thing. They print very well in 0.3mm layer height with a 0.6 nozzle and PETG. That's what I have mainly used. They should work. I don't see why it wouldn't work with other sizes, but that's what I recommend. So, and once this works for you, you may want to print a complete set, and therefore add your inlet and your shroud. Let me show you what that involves. Import your inlet and your shroud, and for ease I will now delete one link, just so it doesn't get too crowded here on the build plate. Print this and print the shroud and the other piece in that direction. It's always best to print them straight up, because that gives you the best accuracy for the round pieces. Without any supports, the spheres print best in this way. And for this shroud you need a little bit of extra, because this part at the top here is not supported. It's round and the overhang angle here is too large. I would suggest to use the new organic supports for that. So I set support on build plate only, use the new organic supports, organic, then do quick slice. There we have pretty much what we want, except for these, they don't need supports. If you print it together, you can just remove the supports by clicking support material, deactivate, using the hose, also support material, deactivate. And then we have these supports, which are unnecessary in my experience. They are easy enough to break off, but you can of course also block them, which is what I will do now. Support blocker, use boxes. Bigger box. Okay, let's try that. This can also go away. Yeah. Okay. Let's put this on the other side also. Should be fine now. Yeah. They have just the supports here. This little bit of crap on the inside should not be a problem, because this is an inner sphere. The link will this part will snap over there. Should be not an issue with movement. So there you have the supports. And last but not least, what I recommend to do is you can see the seams here. There is a seam, and these straight seams in one position, they become an issue with the movement of one sphere inside the other, because there's one straight line of where there is a little bit of extra material there, some kind of ridge where it doesn't move as smoothly. So what I would suggest also is to use, where is it now, seam random, which generally produces a bit more stringing because seam ends here, then there, then there, then there, there, moves around more, but the seam is then distributed randomly across the whole surface, and that makes the movement much more smooth between the two spheres once they are stuck together. So that's it. Let's see how long this will take. 5 hours and 8 minutes. That's not too bad, I think. The links themselves print much more quickly. All of this should also work with 0.4mm nozzle, but these are the settings that are reasonably quick and they work just fine for me. So I hope that helps you, and yeah, would love to see some makes. So let's do a quick overview of the printed pieces. This is the clamp for attaching the vacuum hose to the column of a drill press. It's an M6 bolt, printed in PET, very flexible, and in 2 parts to make sure you can print it accurately. What you need to do is to slide this dovetail in there. If it's too loose, you can use a few dabs of glue, but it sticks on like this. Then you can put it around the column, add a wing nut on the back, tighten it, and this piece, this is the inlet, this goes to the segmented vacuum hose, slide it through here, then use the hose and attach it like this. So then we have a very small funny sample piece where I wanted to show how thin you can make the this connecting pipe, the straight part, and it has very limited throughput, so it's not really a vacuum hose, but maybe it can be used to protect a cable or something, and it's just a funny test project. It snaps on like this. And then we have these bigger hose pieces where I can show you what I did wrong, and I didn't make this overlap big enough, so therefore they disconnect quite easily. What I should have done is made this a little bit longer, then you would have a harder time disconnecting it. Then we have these pieces to once again show the smaller size. This is about 2 cm, and the adapter pieces. You can have these and connect it to big parts. Like this, for example, would be the vacuum cleaner inlet, and then you can put like that. So that's the adapters and some smaller sample piece. Then we have the inlet and outlet pieces. This is what I call the outlet, which fits for my Makita shopvac parts. Just sticks in there, and you could then connect it to this part. If it's useful, I do not know, but it matches. Okay, let's leave it down. This is the inlet part, just as a separate piece. Sticks on here, just fine. Then we have the main segmented vacuum hose with the default parameters given in the FreeCAD file, and it's the right amount of stickiness and ease of snapping it in there. You can see here I forgot to randomize the seam and had to sand it a bit. These parts, however, they work just fine, like they are. So, and for the start, we obviously have the pass that goes to the shopvac. And for the end, I first started with this piece, which is basically the final shroud assembly cut off, but this does not suck good enough. The drill throws the chips away in this direction, and it's not good enough. Or my shopvac is too weak. Whatever's the reason there, I don't know. And then we have the final part here, which is the shroud, as shown in the beginning of the video. Yeah, so there you have it. Some sample pieces and the final assembly.